Hello, in this chapter what we're going to be talking about is gases. All right. Now the first question states a sample of argon gas has a volume of 735 milliliters, a pressure of 1.20 atmospheres, and a temperature of 112 degrees Celsius. All right. What is the final volume of the gas in milliliters when the pressure and temperature of the gas sample are changed to the following if the amount of gas does not change? So what we're going to be doing is we're going to be changing the pressure and the temperature and seeing what happens to the volume of that argon gas. Before we get started, we need to convert the temperature into Kelvin. And in order to convert this temperature into Kelvin, we must add 273 to that. And upon doing that, we're going to get 385 Kelvin. Remember, the Kelvin scale is going to be the absolute value, or absolute temperature scale is what it's referred to. It's mostly used by scientists and not so much in the nursing or healthcare fields, but it's mostly used in science. Now, what we're going to do now, what would happen if we changed the pressure, all right? So we're going to call that second pressure P2. And that second pressure is going to be 658 millimeters of mercury, all right? Now, and the temperature, T2, write that over here, T2 is going to be equal to 281 Kelvin, all right? So it's in blue. Now we have an issue here. The temperature units are in the exact same unit. So this is going to be in Kelvin, that's in Kelvin, that's great. But the pressure one is 1.2 atmospheres. Here it's in millimeters of mercury. Now if we want to convert this into atmospheres, which is consistent with that, we must divide by 760 millimeters of mercury. And that's equal to 1 atmosphere. So 760 millimeters of mercury is equal to 1 atmosphere. Those units are going to cancel out, and what we get for our P2 upon this is 0.866 atmospheres. All right? So we have a P2 of 0.866 atmospheres, and T2 is going to be 281 Kelvin. All right? Now the equation we're going to be using is P1 V1 all upon T1 is equal to P2 V2 all upon T2. Now the question asks, what is the final volume of the gas? So what we're looking for is we're looking for this volume upon changing from this situation to the blue situation, all right? But first what we have to do is we have to solve for V2. And how we're going to do that is we're going to cross multiply. We're going to move P2 down here, and we're going to move T2 up there, such that what we end up getting now is we get V2 is going to be equal to P1 V1, moving the T2 up here, so this becomes now T2 all upon, now we already have the T1 in the denominator, and the P2 is going to join it, all right, as such. Now what we want to do is we want to plug our variables up here into this equation, okay? So we start out with V2 is going to be equal to, now P1, all right, is going to be 1.20 atmospheres, all right? V1 is 735 milliliters, all right? T2 is going to be 281 Kelvin, all right? We're going to divide all that. Now we have T1. If we look at what T1 is going to be 385 Kelvin, all right? And now we have P2. P2 is going to be equal to 0.866 atmospheres. All right? And you see something kind of interesting that happens with the units here. You can see that the kelvins cancel with the kelvins. You see the atmospheres cancel with the atmospheres. And what you're left with is you're left with units of milliliters, right? You go and you do this calculation. And what you're going to do is you take 1.2 times 735 times 281 divided by 385 and divided by 0.866. And what you're going to end up getting is, this is equal to 743 milliliters. Right? You get 743 milliliters from doing that change. All right. Now what we're going to do is we're going to change the pressures as well as the temperature for the second part, but we're going to leave the first part the same. So P1, V1, T1 are all going to remain the same. And what we're going to do is we're going to change the temperature and the pressure. All right. And what this is going to show you is that the volume will change as either the temperature or the pressure changes, and vice versa. All right. You can change the temperature and pressure of a gas, and its volume is going to change. Or you can change the volume of a gas, and its temperature and pressure are going to change. All right. So P, V, and T change as you change any one of those variables. All right. Sorry, it's taking me a while to erase this. But it's kind of, I think the hardest thing here is basically solving that equation, the very first equation. All right. Now the second part, what we're going to do, I think I used blue for that. The second part is we're going to leave V1, T1, and P1 all the same. All right. And now P2 is going to be equal to 0.55 atmospheres. So this is nice that the units are going to be exactly the same. All right. And T2 is going to be equal to 75 degrees Celsius. Well, once again, we have this in degrees Celsius. We have to convert it into Kelvin. You must do that. The temperature of this has to be in Kelvin. It will not work if you leave it in degrees Celsius. So to this, we're going to add 273 to this value. And what we get is we get 348 Kelvin is what we get. Now, if you recall the equation we used, we're going to use the exact same equation before. We're going to use P1 V1 all over T1 is equal to P2 V2 all over T2. And once again, we're going to be solving for V2. All right? And so if we solve this equation for V2, once again, V2 is going to be equal to P1 V1 over T1. Now, that's what we start with, but we need to move this T2 up here, so this becomes now T2. We're going to move the P2 down there to join the T1. All right, so we have P1, V1, T2 all over T1, P2. It's a mouthful, isn't it? All right. Now, let's get ready to plug these in. All right, so P1 is going to be equal to, let's go back to here. Let's show that we're going to be solving for V2. All right, V2, that's what we're looking for. We know that P1 is going to be 1.20 atmospheres. All right. We know that V1 is going to be 735 milliliters. All right. We know that T2 is going to be 348 Kelvin. So that's going to be 348 Kelvin. All right. Oops, my marker is running a little low, I think. All right, grab a different one. T1, so now T1 is still going to be our 385 Kelvin, all right? And now our P2 is going to be 0.55 atmospheres. 0.55 atmospheres. Let me just make sure that divide is there, all right? Now if we look at what's going to happen to these units, once again, the atmospheres cancel, the kelvins cancel, and when we go and do this arithmetic, let's take 1.2 times 735 times 348 divided by 385 divided by 0.55, what we get for new volume is going to be 1,449 milliliters, or that's going to be approximately it's too late in the night, 1450 milliliters. So it's going to be 1450 milliliters is what that's going to be approximately. All right. Okay, so that we'll do one more example problem on this. I just want to show you what to do so you get good and comfortable, familiar with doing these types of problems. They're really not too bad. I think the hardest thing is solving this equation for V2. It just takes a little bit of algebra. But you can see what happened here was that we changed the volume, so we changed the pressure. We went from 1.2 to 0.55, so that's a much lower pressure, and thus the volume increased substantially because of that. All right, so the molecules aren't going to be nearly as close to each other, and thus they can occupy a greater amount of volume or space. But yeah, these gas problems shouldn't be too bad for you. They should be pretty straightforward and kind of easy. Let's see. Let's get to the next spot as soon as I get this erased. But this pressure equation that we're using is actually called the ideal gas law. And that has to deal with what ideal gas is. That's a little beyond the scope of this class, but an ideal gas law is the actual equation is going to be PV equals nRT. All right, so the next one says that our pressure, now we use blue for that. So our pressure, so that's going to be P2. All right, so P2 is going to be equal to 15.4 atmospheres. So now we're looking at a much, much, much greater pressure. And our T2 is going to be equal to a negative 15 degrees Celsius. And once again, we need to convert this into Kelvin. So we're going to add 273 to this. And what we end up getting is 258 Kelvin. All right, so our temperatures decrease somewhat. We're going to use the exact same equation. I'm not going to derive it, but we're going to use V2 is equal to P1 V1, and this would be T2 all upon T1, and this will be P2 is what that is. All right, so that's going to be the equation we use. All right, so let's just start plugging into it right now. All right, so P1 is going to be the 1.20 atmospheres. All right, the V1 is going to be 735 milliliters. All right, now the T2, so we have T2 is going to be 258 Kelvin. All right, we're going to divide that by now T1. All right, so T1 is the 385 Kelvin. All right, and P2 is going to be now the 15.4 atmospheres. All right. Once again, what's going to happen to our units is the kelvins cancel with the kelvins, the atmospheres cancel with the atmospheres, and we're left in units of milliliters. We go through and we do this calculation. So you take 1.2 times 735 times 285 divided by 385 divided by 15.4, and our volume for V2 is going to be equal to 383.8 milliliters, or we can call this approximately 384 milliliters. Let's see. So now we're going to move on to the next question. So the next question asks, in a gas mixture, the total pressures are, so argon is going to be 415 millimeters of mercury, neon is going to be 75 millimeters of mercury, and nitrogen is going to be 125 millimeters of mercury. What is the total pressure in millimeters of mercury exerted by this gas mixture? All right. Now we have three gases. All right. And what we have, let me get my notes over here. And what we have is we're going to have pressure of the argon. All right. Pressure there. Then we're going to have the pressure of the neon, and then we're going to have the pressure of the nitrogen, and that's going to be equal to the total pressure, right? So the total pressure is going to be equal to the pressure of the argon plus the pressure of the neon plus the pressure of the nitrogen, all right? So now if we write these values in here, I keep losing my, so pressure of the argon is equal to 415 millimeters of mercury. Pressure of the neon, right? Pressure of the neon is going to be 75 millimeters of mercury. And now the pressure of the nitrogen is going to be 125 millimeters of mercury. All right. And so we're just simply going to add these up. So this becomes 415 millimeters of mercury plus 75 millimeters of mercury plus 125 millimeters of mercury. If we sum all those up, that's going to give us a pressure of 615 millimeters of mercury is going to be equal to now our P total. Okay, so that's going to be equal to our P total. Thus, this concludes the problems for gases. If you happen to have any other questions, you're free and welcome to ask me any questions you want pertaining to this. Once again, if you need help, let me know. Have a good day.